Assalamualaikum and hi. In this lecture video, we are going to discuss about differentiation using first principle. Before we discuss how to find the derivative of a function using the first principle, let us discuss first in brief the geometrical definition of the first principle differentiation. Let us study the function y equals to fx. Let px1, y1 be an arbitrary point on the curve y equals to fx, and qx2, y2 is another point on the curve. Based on what you have learned in secondary school, you know that you can find the gradient m of the line PQ by y2 minus y1 over x2 minus x1. As you know that y is equals to fx, then y2 it is equals to fx2, and y1 it is equals to fx1. Therefore, this formula can be rewritten as this. Since delta x is the difference in x values, which is x2 minus x1, then this can be rewritten as this. We know that delta x is equals to x2 minus x1. We can rearrange this to make the x2 become the subject of the equation. Then we have x2, it is equals to x1 plus delta x. Thus, we can substitute x2, it is equals to x1 plus delta x, and this gives, from here, we can return to here. Now, let us consider different cases where the point Q closer to the point P. In this figure, you can see that the point Q closer to the point P compared to this figure. In this figure, you can see that the point Q is closer to the point P compared to this figure. It can be observed that when the point Q approaching P, the x2 value approaching the x1 value. As a result, the delta x value approaching 0. Therefore, when the point Q gets closer and closer to P, the line joining the points P and Q is thus approaching the tangent line at point P. This idea has brought to the definition of the gradient of the tangent at point P that is given by limit delta x approaching 0, fx1 plus delta x minus fx1 over delta x. Based on topic 2.1, we know that m it is equal to dy dx, which is actually f prime x. The process of finding f prime x using this definition is called as differentiation from first principle. To simplify the notations here, we replace variable x1 with x and delta x with the variable h. Thus, we have this formula as what you have in the lecture slide. So what are the steps required in order to use first principle to find the derivative? The first step, you know that you have the function f(x). In the second step, you need to write an expression for f(x) plus h. The third step, substitute f(x) and f(x) plus h into the formula for the first principle. The fourth step, you need to simplify the expression. And the final step, which is step 5, you need to evaluate the limit by using the formula. Let us consider the first example. Use the first principle to find the derivative of f(x) equals to x squared. So you know that you have f(x) equals to x squared. The second step, you need to write the expression for f(x) plus h. So what you have to do here, you need to replace in here with x plus h. Okay, we replace x with x plus h. Therefore, we have x plus h squared. So we want to expand this. Therefore, we have x squared plus 2xh plus h squared. And we know that the formula to find f prime x by using the first principle is equal to limit h approaching 0, f(x) plus h minus f(x) over h, where this is equal to, okay, now we substitute this into here. So we have x squared plus 2xh plus h squared minus f(x). We have here f(x) is equal to x squared. So minus x squared. Sorry, I missed the part for the limit. So we will erase this. Okay, it is equal to limit h approaching 0 over h. So now we simplify this expression. We can eliminate x squared here. So what's left is limit h approaching 0 to xh plus h squared over h. Okay, if you use now with the direct substitution, then you will get 0 over 0, which is an indeterminate form. Therefore, we cannot use direct substitution yet. We have to do something with this expression. In this case, we will use factorization. So from there, we have limit h approaching 0. We will factor out the variable h times 2x plus h over h. From here, we can cancel out the variable h. Therefore, we get limit h approaching 0, 2x plus h. At this stage, we can try with direct substitution. So if we use direct substitution, where we substitute h equals to 0, then we have 2x plus 0, which is equals to 2x. So this is the answer for f prime x. If you remember the formula for x prime h, okay, we will discuss about this formula later, but if you still remember, whenever you have fx equals to x power of n, then f prime x, it is equals to n times x power of n minus 1, and this is the one when you use the formula, okay? But in this case, we cannot use this formula. This is just for checking purpose. So if you see here, we have x squared. Then if we use this formula, then we should get 2x power of 2 minus 1, which is 2x, where it is equals to what we have here, 2x. Now let us consider second example, where this question is based or is from test question for semester 2 2019-2020. By using differentiation from first principle, find the derivative of fx, which is equal to square root 1 minus 3x. You know that you have fx, it is equals to square root 1 minus 3x. You need to write the expression for fx plus h, where in this case, you need to replace this x with x plus h. So we'll get square root 1 minus 3x plus h. Okay, now we will substitute this into the first principle formula, where f prime x, it is equals to limit h approaching 0, fx plus h minus fx over over h. We have fx plus h is square root 1 minus 3x plus h. So we will substitute that. Square root 1 minus 3x plus h minus fx is square root 1 minus 3x. So square root 1 minus 3x over h. Oops. Over h. Okay, I guess I should I should move a bit this to the left so that we can. Okay, what we will do in this case, if you see that, if you try with direct substitution, you will get an indeterminate form, which is 0 over 0. Therefore, we should either use multiplication with conjugate or differentiation. As you know, based on chapter 1, when we have the root sign, then we should use the multiplication with conjugate. So in this case, the conjugate is square root 1 minus 3x plus h plus. Okay, here we have minus, so the conjugate here will be minus, change to plus. Square root 1 minus 3x. Okay, over, we will multiply with the same conjugate. 1 minus 3x plus h plus root 1 minus 3x. Okay, and from there we get limit h approaching 0 when root 1 minus 3x plus h times root 1 minus 3x plus h, the root sign is eliminated. So we have 1 minus 3x plus h, and then minus times plus, we get minus, and then we have root 1 minus 3x times 1 minus 3x, we have 1 minus 3x. You must have the brackets here. Over, for the denominator part, you don't do anything. You just remain as it is. Okay. So h multiply with root 1 minus 3x plus h plus root 1 minus 3x. Okay. Where this is equal to limit h approaching 0. Now what we have to do is we need to simplify this expression. So you'll get 1 minus 3x minus 3h. In order to simplify, we need to expand the numerator part. So we get 1 minus 3x minus 3h minus 1 plus 3x over h times root 1 minus 3x plus h plus root 1 minus 3x. Okay, from there, 1 minus 1 is 0. 3x minus 3x is also 0. So what's left is equal to limit h approaching 0 minus 3h over h times root 1 minus 3x plus h plus root 1 minus 3x. And since we have here h in the numerator and also h in the denominator, then we can cancel out the h variable. So what's left is limit h approaching 0 minus 3 over root 1 minus 3x plus h plus root 1 minus 3x. If you see here, we still have this because we have the variable, we still have the variable x on the right side. Okay, so as long as you have the expression with x variable, then you should have this. So what's next? Sorry, I'll try to... Okay, so from there, it is equal to... So now we can try with direct substitution. So we substitute h equals to 0 into this expression. So what we have here is negative 3 over square root 1 minus 3x plus 0 plus root 1 minus 3x, where this is equal to negative 3 over square root 1 minus 3x plus square root 1 minus 3x. If you see in the denominator part, we have here root 1 minus 3x plus root 1 minus 3x. It is like this is a plus a. A plus a, it is equal to 2a. And our a is root 1 minus 3x. Therefore, we get negative 3 over 2a, where a is 2 times root 1 minus 3x. Okay, again I repeat, here is like you have like a plus a. A plus a, it is equal to 2a. Therefore, we get 2a, here 2a, where a is root 1 minus 3x. And from there we get, oh, okay. So that is the final answer for f prime x by using the first principle. Okay, I guess 2 examples are enough because you have more examples in the lecture slide, and you can try to do the exercises from tutorial. That's all. Bye-bye.